Yeah. Uh, Firas, so shall we start the session?
Yes, Mr. Adnan, I'm very ready to do that. Are we
Yeah.
going to wait for the rest, or we shall start? What do
I
you
think we
advise?
can start the session. People will join.
Okay, let's do it.
Okay.
So I will start sharing my screen. That's
Sure.
great.
So, good afternoon, everyone. This is me, Adnan Ghori, the founder and director of iWorkstation, and along with me is Firas Noori. So, I'll give you a brief introduction about Firas. Firas is an instructor in the Department of Architecture at Ajman University from Abu Dhabi. Firas Noori is also a certified Autodesk professional in Revit architecture. He is also an educational influencer with more than 8,420 subscribers on YouTube. So if you find on YouTube, you can get a lot of videos and good content about computational design, Revit, and about BIM in his particular channel on YouTube. So welcome, Firas. We welcome
Thank you
you
very
all
much.
for the iWorkstation BIM series.
Appreciate it. Thank you for the introduction, Mr. Adnan. Appreciate that. So I'll start up sharing my screen now. I think you get if you see the image now, my dear.
Yes, it's clearly visible.
Beautiful. So, hi everyone. My name is Firas, and I am an architect, and I'm from Ajman University, an instructor at Ajman University, UAE in Ajman, and I have a master's degree in sustainable design from the University of Sydney, and another master from the University of Technology and Architecture Engineering. As my dear friend Mr. Adnan already introduced me, I'm also an author for a new book has been just released a couple of months for Revit parametric design. It's available now on Amazon, and I'm also a certified Revit and Autodesk expert. So today I will be taking you in a quick journey in the concept or the idea of a computational design and how we can introduce ourselves to this new and important term in the architecture field. Uh, Maybe most of us will cover over the terminology of the parametric design and computational design and generative design. And this is, it's a kind of a mixed up, to be honest, with the amount of terms available and that can be dealt with during the current rapid development in the applications and the design method. And probably the best and the first actually person talked about that is, the father of the computational thinking, Seymour Papert, and the gentleman who's talk about that, or first mentioned the computational as a thinking way, not as a design. In 1980s, he was an MIT professor, and he's actually behind all the artificial intelligence revolution and also the computational thinking. The gentleman started the whole idea when he tried to make a small robot with the ability to very basic ability to think, and how he actually programmed the computer to allow that machine or the machine actually to think and simplify it, and a type of problem or a bigger problem, simplify it and then abstract it and introduce that to the machine so it can do that job by itself. By doing this, he technically opened, a limitless science that all based on robotics, artificial intelligence, computational design, generative design, parametric architecture, all that opened by this work that he done in 1980. He passed away in 2016. And the whole thinking in a way of computational comes to the thought process involved in formulating a problem and expressing its solution in such a way that computer can effectively carrying it out. So I'm trying to give you a couple of definitions, and also within the definition, I will show you and explain for you the terminology and the idea behind each one of them. So if we step a little bit forward to the architectural part of it or to the design part of it, the computational design in its first definition, it's actually, it's included or described as a design that harness the computer power and to enable the production of a multiple and complex design option. So from this definition, and I will present for you like 4 or 5 of them, and each one of them, and of course it's a fresh field, yet it's a really rapidly growth one. And you'll find lots of definition, and from each definition, we can understand, or we can make our own definition actually, to try to better understand what is the whole fuss about in the field of architecture and the field of design. Uh, so if we have a look, I highlighted the keyword that I found it. It's a design harness the computer. And that's the most important part. The computational design actually have to be, there is a cases where it can be done without computer, I know, but let's say 99% or 98% of it should be or included within the computer environment. That can provide multiple, that's number one, and also complicated and complex design options. So that's a very basic lighting fixture example that I have done recently, and it's basically a rotated pieces of wood and or elements around the vertical axis around the point. How far they goes, you can control that, and how high they goes, it's just a helix creation. And with a basic, very easy formula you can create, you can tell and create by using computer and endless possibilities of what you have. So of what you actually think. You just put an idea in your head. The idea is I want a vertical rotated element around a point. And that's heights of them, or those heights of them are actually different. This is the idea. I don't know what shape it can, that's what we, or I want actually to carry on for you as a designer, whatever the field you are in, to stop imagining the end result and think of the process of the design. So now I don't want to imagine the end up result, but I'm saying, what if I can make a rotated element goes 360 or even more around a vertical axis, and how that could be, and what's the possibilities that I can harness. And the result is almost unlimited options. That's the whole objects you see is one computational model. It couldn't be done in the real life scenario because you cannot make endless option physically. That will be very painful, useless process in order to test which is the best to be picked on. But in computer, you can make these options in a couple of seconds. And all of them are the same. For example, in this one just rotated 360 degree, while in this one it's rotated 720 degrees. So it's 2 loops here or 3, while this one loop, and the one on the top far right is just 180, which is a half a loop. And imagine if we add, I'm talking here just to the rotation. Imagine if I change the thickness, the radius, the heights, the overall differences of the heights, like this one to make it shorter. I can include more options to get more results. So that's what I can think, that's what I can understand from this very basic definition about the computational design. A second one can tell me it's not just one algorithm, and it's not out of the shelf process, but rather, and again, I yellowed the keywords that trigger my brain to get more example to explain. It describes an approach, okay, that it can define a series of instruction and rules and relationship that actually can make me think of the steps or the procedure of the design rather than the end of geometry. And of course, it should be computable. You're going to hear those terminology. It should be a computable problem. So it's a problem you can calculate to solve, not things about feelings, things about unmeasurable matter. So it should be computable in order to get your computational design understood and work. And it also should be done with the computer. So I'm going to ignore those because they're going to keep repeating themselves. And I'm going to look at this time approach, algorithm, and the definition of a procedure. So what is this? What does that mean in order to understand the computational design for you? it's an algorithm. So you only have to put a steps of making something, and you can use the algorithm to, to prepare a nice meal, which I love, and you can make that steps to make a rocket. You can make that steps to make a design. That's the algorithm. It's the basic links of a group of situation or steps that not necessarily should be, in a sequence, but even can be, directed, looped, canceled, conditions. And I don't want to go in all the algorithmic basics and algorithmic concept, but I wanted to explain the concept. And the best example that I prepare here, that's the book for Barry Wood, with his book, Parametric of Element Design. It's a beautiful book, and I highly advise you to it. And it shows the recursion techniques. And it's basically a rectangle that actually has, a smaller rectangle inside, and then it goes smaller and smaller, and also at the same time it's rotate. So it's a nested sequence of square inside an initial square. So look at the way we think it. Look at the way of the algorithm that you need to understand in order to do such a design. You have to understand that there is a rectangle, and that's, or a square. So you have to make a square in the beginning. And of course you have to copy that square. Maybe it will be in the same place. And then you have to scale that object or that square, and then you have to rotate it. And of course, there is nothing fixed in the computational design. There is something fixed, of course, but the majority of the work, it should be dynamic or variable. Here, the variable will be later have a VIP variable, like X and Y. They are important variable in the design, but they are really important variable. We're going to later on call them parameters, which is the ones who help us to compute, the overall design. So the variables here are the X and Y, for example, for the factor, if you want to distort it equally or not, and then how you can rotate that element and how much actually you want to rotate that element. And in this case, for example, it's 45, and let's say around 0.7% as a scale down. The important issue to achieve this iteration is the value of I, which is how many times you want to repeat it. For example, this shape is only 5, this shape is around 7, around 9, around 12. So in the algorithm, you are telling the computer what to do. You are telling it, create a box, rotate that box, scale that box, and keep doing that for the last copy until the I value has been reached, which is the iteration value. So let's say if I said 1 here as an iteration value, so the achieve, if it's yes and no, it say yes, and it will give you that result. Just one time, one copy, one rotation. If you say no, it hasn't been achieved because you make 5, it's gonna go to loop to repeat itself and keep rotating until you get this shape. It depends, of course, on the rotation value, because this is the 45-degree and this is, I think, 10. So that's the algorithm. This is the way now we have to understand. If you want to do a computational design, you have to have an algorithm. You have to have a steps that each one of them usually lead to another, and each one of them could have a possibilities that the computer should, achieve or do in order to create the required shape. What is the shape? I have no idea. It could be that one. It could be the other one in the top. No one actually can understand exactly what the shape is, but rather we thought of the process of doing that. And a third definition, now it's said it's the happening approach that design computationally that focus on developing the process. Again, we are talking about a process or procedure that would create, not focus on the design itself, but rather it focus on the procedure of it. And of course, it have the benefit to make more money, save more money, more time, and save the effort. And the most important thing is to create or to achieve the creativity. So now again, the concept of the procedure and the need to reach creativity. So if I think it, or if I, try to link that to the architectural way of presenting the design, you're going to see that there is a geometry, and that's the traditional way that our students show, or any architect show their concept, that they are related to the end result, not to the process of it. And even when they do that, they do that for one shot, one kill. You know, like you do that for one thing that give you the object or the geometry or the final shape that happened to be existed in your brain. He is or she is describing the procedure to reach that one goal. That's the traditional thing. So he has a square, or a box, or a cuboid, whatever you want to call it, depending from the background. He chop another cuboid out of it, and then he chop from the top one, or add another one. I have no idea. And that been displaced or moved, and that's how you get to the final result. A geometry, an O shape that's been taken small or subtracted from it, a group of L shape and another boxes, and then another part has been replaced upward, skin goes down, blah, 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 all the detail. That's the end result. That's the only end up result. And you can see there is only one option, and it is, you know, a fixed steps to reach the target. This is the traditional way of design thinking. And on the other hand, in the computational design thinking, this is why there is lots of architects and lots of, you know, theoretical and critics, you know, they till now fighting that is it a computational design? Is it a way of thinking? Is it a design method, or it's just a tool? You know, like this is an important thing. And I am one of those who are in favor, of course, of it's a design method, because we have a design strategies totally different and more complicated, to be honest, and can achieve significant, much more better results rather than the traditional architectural design method. Anyway, so in this method, look at the procedure here. This is the Snowflake Tower. It's for Lava Architect, presented for the first time with Mr. Tobias Wilsa when he visited us at Ajman University. Uh, One of the few universities in UAE managed to create such a successful workshop at that time to bring one of the most innovative architects in the concept of computational design. And the gentleman came for a couple of days, and he presented for us one of the way that he designed with his team, Lava Architects. He designed this masterpiece here in Abu Dhabi. That's the project is, I think it's still in concept progress. And the idea behind it, that's they defined a parametric limitless or unlimited plan that can be generate any shape you want. And the process or the procedure to create the plan is different from, or how to create the form is different, because the plan itself is not fixed. And you can see that each section, each plan, you slice this masterpiece, you're gonna get a different plan. And the first thing that comes to your brain is to draw those elements. If you are a nerdy guy or a a guy like me, you're gonna put in a vertical line in a 3D Studio Max, and you draw those shapes individually, and voila, what's new? No, this is not a computational design, my friend. You are just making an organic modeling. And that's another misconception that lots of architects fall in. When they see an organic object, they say, yes, it's parametric architecture on computational design. No, my dear, there is a big margin of difference between them. And these, whatever you believe that or not, are the same object. And they've done in this shape. I remodeled this myself. The gentleman in the beginning, he created in Rhinoceros, and I remodeled the whole thing in Dynamo. That's another software that you can achieve computational design in it. But the concept behind it, and that's from their website, and from another website also was, I don't know how to pronounce that, to be honest. It's beneath here, the references. And the concept behind it, let's see how it differs from the normal process. He have defined points that represent this, you know, this concaves or these holes that he have in the plan. And those points are P2, for example, and they are distance in 120 degree, you know, from this point. Those points, this P2, are actually the radius that's going to create these curves. Or actually, they can control. So if you push them more that way, you know, you're going to go 0 here, and then you give them 1 here, 2 here, 3 here, 4 here. So when you move those guys outside, you're going to end up by having different shapes. What type of shape you're going to have? No one knows until you ask the computer to generate, and then you have to pick from them what you like. and so on. For P1, they actually control the pitches of those lines. And again, they are making themselves, or the movement is polar system, not a grid, normal grid system. Same thing for P3 to provide how fat or how puffed this curve is. And, or these curves are actually, and the end up result, what you think is this shape, which is completely wrong. What you get is unlimited shapes. So the way we think, or the way computational designers think, different. There is no options. There is no one option. There is whatever he pick for the design, which is 1, 2, 3, 4, 5, 6, 7. Believe it or not, they are the same plan. And that's the first time someone talk about a parametric generation outline, a shape that generally, a plan that have no fixed shape. And you can control which one to pick, and he just accumulate those, and then he created the loft that you're talking about. So anytime he change any values, if he want from those, this shape will dramatically change to a totally different tower within a couple of seconds. So that's the way the computational design thought, or that's how you think with the computational design. It's a different design or different architectural approach. I think this one is the last one, and out of the talks, because some of it is not here, we start to be repeated as, which is I like, it's not delay or depend on the traditional way of thinking. It's a computational design to enhance the process, and it must depend on encoding the design decision using a coding language. So now that definition is actually tell us that there must be a coding tool for me, which is for us, it's, they're the same thing. The coding program is the same as the programming type. And of course, you can go with a visual program, or if you are too nerdy, you can go with a textual platform. Of course, no one likes textual platform. Not everyone. Eventually, let's say, do I have to need to learn these? No, you don't need to be scared about it. But that's why they created a visual programming platform like Dynamo. By the way, both of them Dynamo. But 90% can be done in this one, which is an easy. You have an object instead of a point, which is a point that's going to create a point, and another object that can create circle for you. And the rest of the parameter, you can just add them in a fader, like a remote controller here, and you can change the design. That's way much easy. So in order to reach computational design, you have to have a visual or textual. In our case, as an architect, we really hate math for lots of reasons. So visual programming will be easier for us. It's just a matter of to let your brain fight for it for a couple of months, and then your brain start to think differently in how to program. It's not actually how to program, but how rather you design your objects based on the visual programming platforms. So what we get quickly out of those features, 2013, I didn't mention that in the previous slide, first time the concept brought to the reality by Bentley, and the software was named Generative Design, commercially to the first time, even though it's been postponed to 2017 later on. Anyway, so that's the features, or that's how you can understand simply what is generative design. So the design process is defined clearly in a code, not in the designer head. Not anymore. The ideas behind the design, the black box theory, should be changed into a glass box way of thinking, and it should be encoded in an algorithm. So the things and the creativity will not only happen in your head, my dear friend. This is a really important line in here. Of course, it needs to be done in computer. The main design are created in one advanced design option. Usually, it can lead to unlimited design option. When you say unlimited design option, or thousands and even 10,000s of options, this time we are going in a level higher than the computational design, and we reach something we call a generative design. So there is, that's a computational thinking, then parametric architecture, then computational design, and the monster sitting in the top, which is the generative design, which is not, I'm not going to talk that much in this lecture, just to refer for it in this presentation. Of course, you can create complex objects or high quality objects, high precise objects. It depends on how you actually think about it. You have to focus on the process. You're not supposed to focus on the end result. If you are a traditional architect thinking of one geometry, this will flip the way you think. This will revolute your brain to a new high level. It saves the design process. Of course, it's you have to understand and it's open your mind to the concept of design pattern. Design pattern in generative and parametric architecture on computational design are a seriously important terminology. It's covered in elaborative way in the book Element of Architecture, the Parametric Design for Woodbury. He is a genius. I really advise you to understand that, because whenever you look at any building, your brain, after you study this theory, your brain will change that into a design pattern, and that design pattern will immediately change into an algorithm so you can do it, or make the computer do it, not you do it anymore. Of course, you're going to need textual and visual platform to do it. And of course, there will be algorithms. So you have to understand logic and how they actually create a connected logical step. And of course, it will provide tested, filtered, automatic results and solutions. So in order to do computational design, you have to have the ability to decompose it, or deconstruct the problem, the bigger problem, into a smaller problem. You have to understand the pattern recognition. You have to be able to abstract it, make it simpler, and you have to write that in algorithm. So if we have a pyramid as an example, if you look at the pyramid, it's look like a cake model, and again, food, for those who knows me, they will know how I appreciate food. So if I think a pyramid as layers of cake, or a cake model techniques, it's a pieces of rectangular or square object above each other. So what I'm doing now is decomposing the elements and breaking down to its smaller thing, and then try to understand the pattern and look for the similarity that happened in this problem. If it's a very basic geometry, as I'm talking about a basic pyramid, of course, the pyramid as the Egyptian pyramid is way much more complicated, far away from to be a basic, but if I just simplify it. And then I have to abstract it, imagine it is just a rectangle, and the other one is a copy, and it's moved upward on the z-axis, and then another smaller copy in the axis, and decide how small it goes up and up. So I am just focusing on the important information and ignoring maybe the type of cladding that's been added, any kind of in carving or text has been added to the geometry, and just try to abstract the geometry in its basic levels and techniques, so I can, of course, end up by having the algorithm design. And I can show you later on in a different presentations how you actually do that in a more realistic and modern way of a design, rather than just a conversation about it. Of course, one of the three of the famous projects are the fish for Gary architects, Waterloo Station, and City Hall for Foster and Partners. And here they have been replaced by the historical famous example, because those three innovative and pioneer architects was the ones who pushed to use those techniques, and they used the techniques, and they became the advocate to the rest of the architects and designer, to start using these in their own fields. That's also a part of the University of Singapore course procedure modeling. That's one of the best courses you can take in order also to enhance your knowledge in the thing. The presentation that I prepared is a collection of both my work and other work. So I have not only to take the credits, I always love to share the credits for the people who was behind teaching me this topic, and to encourage to advocate for them too, to give them the full right of it. Here we're gonna have, if you've thought of it now, you're gonna have a computational design, you're gonna have a building information modeling, digital design, parametric architecture, computer-aided design, which is CAD, and then there will be a generative design techniques. Too much terminology, I know it can be confusing. And sadly, I will not be able to cover up this, because I have to wrap it up with like 45 minutes or 1 hour with Mr. Adnan. But if you want to know more, you are most than welcome to attend my second seminar, Generative Design and Parametric Architecture. It will be held on the 26th of May with my dear friend, Dr. Yahya, and at the University of Technology in Iraq. You can follow me on Instagram and on LinkedIn, and I will be posting that link so you can all join for free. So I would love, of course, to explain those terminology and how they actually develop. But as I promised, the concept is to talk about only the introduction to the computational design. So in order to be a computational designer, you must be able to learn one of those tools, like 3 or 4. For me, of course, I will go with the Autodesk Dynamo. Mr. Adnan, do you want to remind me about the time? And you are waiting for a second so I can be silenced and you can tell me that. How long we have?
Okay, like we can take for 5 minutes. Then we can
4 or
take a
5
5.
minutes.
Yeah.
Okay, I will continue that after the break. So
Sure.
I will continue for a 5 minute and then I will allow for a break. Thank you very much.
Yeah. Sure.
So thank you, Mr. Adnan. So to be able to work with the computational design, you have to learn one of those, and you don't need to be really master every bits and pieces and every one of them. Just you can learn the basic to achieve a significant result and make a big change. For me, of course, I am with Autodesk, so Autodesk Dynamo is the one who I always advise you to go. Grasshopper, yes, is a little bit more advanced, I know, but it cannot be deal with Revit, which is eventually what you're going to do, like the way Dynamo is. And of course, there is the generative component for Bentley. So what is Dynamo? Again, it's a visual programming platform that used by a wide range of people to achieve benefits that cannot be provided by Revit itself or any other design platform. And I highlight for you a visual programming just to remind you that, and to illustrate that the visual programming is this way of work, like not a textual one. It doesn't need to be freak out, especially for architects. I know they hate math and text and everything. And again, it's going to need an algorithm to be done, and we already spoke about that. And what type of a platform you can find Dynamo? You can find it as a plugin for Revit or a standalone or core. I think the plugin and Revit will be the Dynamo Sandbox is the standard you can find immediately when you install Revit, but Dynamo Studio, you have to pay for it. And it's a much more bigger and wider than both of them. But the one that we are actually looking at is this one, which is Dynamo for Revit, which is because of Revit itself. And even Dynamo as a plugin is not only for Revit, it can be for Revit, LES, Advanced Styling Format, and also for Civil 3D. So again, who you need or who actually must learn Dynamo or who must computational design, it's almost everyone. So designer, programmer, engineers, architects, and interior design and cost. And of course, they're going to achieve benefits. And I will be talking about the benefits in more detail after the break. So Mr. Adnan, I will stop here, and we might need having a break now. So we can come back after how long do you think? 5 minutes is enough? 10 minutes, 5 minutes? What's
is good enough?
okay?
So guys, we
Beautiful.
can take a 5 minutes of break and then we'll come back again. Firas will continue the session and then we can go for the Q&A discussions.
Beautiful. Thank you very much. So see you all after 5 minutes.
Everyone of you can join back again with the same link after 5 minutes. Okay.
Great.
Yeah.
Great.
Thank you.
Thank you. Thank you.